Given that e to the minus 2x equals 4, find the exact value of x. The diagram shows this curve. The curve crosses the y-axis at the point A, the x-axis at the point B, and has a stationary point at M. State the y-coordinate of A, find the x-coordinate of B, find the x-coordinate of the stationary point M. The shaded region R is bounded by the curve, the lines x equals 0, x equals log 2 on the x-axis. Find the volume of the solid generated when the region R is rotated 360 degrees about the x-axis, given your answer in the form p over q pi, where p and q are integers. So let's have a little look at this then. Part A first of all then, I'll just do it up here, save a bit of space. Write this in log form. Log 4 is minus 2x, isn't it? That just comes down, and the e drops down to be the base number of that value 4. So that tells us then x is equal to minus 2 comes below, so it's minus a half, and then 4. So this would be 4 to the half, wouldn't it? Minus log of 4 to the half when you move the power up, and that's 2. And then move the minus 1 up to be 2 to the minus 1, and then is log a half. So that's part A. Now part B then. Part 1. State the y-coordinate of A. So we've got y equals 4e to the minus 2x minus e to the minus 4x, wasn't it? X equals 0 then gives y is equal to e to the 0 is 4e to the 0 minus an e to the 0. 4 times 1 minus 1 is 4, minus 1 is 3. So that's part 1. Part 2. Now find the x-coordinate of B. So when does y equal 0? Y equals 0 when this is 0. There's an e to the minus 2x common, so put that outside a bracket. We've got a 4 here, minus, and we need another e to the minus 2x, don't we? Because times you add the powers to get minus 4. This never is 0, so the solution comes from this part. E to the minus 2x equals 4, and that was the solution to the part A, wasn't it? X is equal to log of a half. If we look back up, let's just have a quick look. There it is there, and x was log a half. So that's part 2. Part 3, find the stationary point and the x-coordinate of it. So we need to differentiate. Y dashed is equal to the minus c to the something differentiates to e to the something multiplied by the something differentiated, which is minus 2. So the minus 2 comes down to be with the 4 to make minus 8 e to the minus 2x, and similarly the minus 4 comes down plus 4 e to the minus 4x. When does that equal 0? Now there's a 4 common and an e to the minus 2x common. Then over here we're going to have an e to the minus 2x, aren't we? So that when you times you get e to the minus 4x times 4. Minus 2 for the second one, isn't it, to get minus 8. This is never 0, so this solution here is when e to the minus 2x equals 2. Write it in log form, so minus 2x then is equal to the natural logarithm of 2. X is equal to, move the minus 2 down, minus a half log 2. So there's part 3. Now we need to find the volume. The volume is spun around the OX axis between 0 and log 2. Here's the disk. I've drawn it in already. Pi y squared is the height, y squared is the radius. Cylindrical volume delta V is pi y squared times its thickness delta x. So our volume then, part 4, I'll put it as V. It's clear what we mean. 0 to log 2 of pi y squared dx, which is equal to pi, the integral between 0 and log 2, of y squared. Now y is here. If we square this like we would square a quadratic, we get 16e to the minus 4x, minus 2 of the middle terms, so that's 8, e to the minus 6x, plus, and then we get e to the minus 8x, don't we? When we times that term by itself, because you add the powers. So that's what we've got there then. So that's equal to pi. Let's integrate it term by term. E to the minus 4x integrates to e to the minus 4x over the minus 4. So there'll be a 16 on top. cancels with the minus 4 to leave minus 4, e to the minus 4x. This one similarly, the minus 6 comes underneath, so we need a plus. 8 over 6 is 4/3, e to the minus 6x. And this one is going to be, the minus 8 comes underneath, plus over a minus is a minus, e to the minus 8x over the 8. And that would be between 0 and log 2. So let's work out what we get then. We get pi. Now minus 4 lots of. Now log 2 times minus 4. Let's just do this one to illustrate it. And it's e to the power, isn't it? So that we can write that as e to the log of 2 to the minus 4. And that's just 2 to the minus 4. So here we can just put 2 to the minus 4, can't we? Plus 4/3. 2. And this will be 2 to the minus 6, won't it? And similarly, minus 1 over 8. And this will be 2 to the minus 8. It's got minus 8 instead of the minus 4. So it's 2 to the minus 8. That's the top values. Take away the bottom values, put 0 in. E to 0 is 1, so it's minus 4. Plus 4/3 minus 1 over 8. Close bracket. Equals pi. Now what have we got? We got this is 1 over 16. 4 on top is minus 1/4. This is, the 2 of the 2's will cancel, won't they? So we'll get 2 to the 4, which is 4/16, 1 over 48 here. And this one, this is 2 to the 8 times the 2 cubed is minus 1 over 2 to the 11. Which is quite large. So those three, there's no multiplication outside, so I can just write those three terms. Minus and a minus is a plus, that's 4. Then it's minus 4/3 plus 1 over 8. Okay, that's what we've got then. So why don't we work out the fractions first and then worry about the 2 to the 11. So let's tap those in then. We've got minus 1/4, minus 1 divided by 4. Plus 1 divided by 48, plus 4, minus 4/3, divided by 3, plus 1/8, divided by 8, equals 10495 over 248 is what we've got. 10495 over 2048. Okay, let's just check that again then. I've got an answer here, which I don't want, so I need to go back here. For some reason I've got an answer from before and I don't want that. So let's just go back here and I need a minus 1. That's it, so let's see what we got there. 41 over 16 is what we've got there. Let's put that in. That looks a bit better. Minus 1 over 2 to the 11. So let's see what we've got here then. So it's 41 divided by 16 minus 1 divided by 2 to the power 11. We can put it in like that. No harm. Decimal. It's not giving me a thing, so I'm going to have to find out what that is. So what is 2 to the power 11? Is 2048, so it's minus 1 over 2048. Divide 16 into that to see what we need to scale up by. 128, so 41 times 128 times 41 then. 5248. 5248 over 2048. All times pi, of course, minus 1 over 2048, which is 5247 over 2048. Lots of pi.